Good morning, everybody. Warning.
All right, can you see the screen? Can you see my screen? Can you see me
Yes,
right
sir.
enough?
Yes, sir.
All right, good. Just wanted to make sure. All right, so let's get started, guys. So the objective for today is to do some quick revision of what we have covered and to go through this classwork that we did. Session is being recorded for persons who cannot attend. And I also want to go through the two questions that I sent in the group. At least those two. If you can get through those two, and maybe add another one within the time. I don't like when the Saturday session is too lengthy. I don't like when the online sessions are too lengthy because I feel like people become disinterested after a while. All right, so I want the session to maybe an hour, hour and a half, but no more than 2 hours for sure. All right. So this on the screen here is the classwork that we did on Wednesday and on Thursday. All right, so I'm just going to go through it quickly. But my main objective really is to get to those questions that I sent in the group so that persons who did them will learn from the mistakes. And there are certain things that we will be able to emphasize that will then enhance the understanding of what we're doing. All right. So in this classwork, we are given this function. It's a quadratic function. All right. They call it g of x this time. But remember, they can refer to this thing in any way they please. They can even call it y. The important section of this expression here is a quadratic function. And what they want us to do with this is to convert this expression into this form right here, which is called the vertex form. All right. Right. They want us to go from this form to this form. So this is the standard form, and this is the vertex or turning point form, because this form tells us where the turning point is. Now, they gave the question A, H, and K, but as I explained in the class, CSEC tends to change how they express this thing from exam paper to exam paper. All right. And so if we learn a method using H and K, which is a standard way to express it, let me not say the standard way, it's the most frequent way of expressing the standard form, the vertex form. This that I have on the screen here. It's a way that you'll see it mostly, but from time to time, CXC will make changes. For example, they will put a minus here on some question instead of a plus. And if you learn, for example, to calculate the H when this is a plus and use that same formula, in that case, the H will be B over 2A. So in some class, that's what they will teach you. H is B over 2A. But if CXC changes this to a minus and use B over 2A still, then the H that you get, and you keep the minus, then the H that you get is not going to be correct. And that's just an example of what can go wrong. All right. So because CXC changes how they express that thing from time to time, what we have done, we have said, okay, instead of using H plus K, instead of using this expression, we're using xt and yt. So I've written that expression in this way. So they give us g of x equals 3x squared minus 8x plus 2. And I'm saying instead of using the h and the k, we're going to write it as a bracket x, note I'm putting a minus xt squared plus yt. And what's the significance of this? When we calculate the value that goes here, that will be the x value at the turning point. Remember, the quadratic function has a turning point. It has either a maximum or a minimum turning point. This one will have a minimum turning point, and how we know it has a minimum turning point is that the squared term is positive. This a value. When the a is positive, the graph will have a smile shape, and when it has a smile shape, it will have a minimum turning point. And that minimum turning point will have the coordinates that we have here and here. That is the xt and the yt at that minimum turning point. Alright? And so the important thing in this step really is to calculate this value and this value, which then become the coordinates in that turning point. All right. So how do we get xt value from here? That xt value is a different color. That xt value that is coming here is equal to minus b divided by 2a when we're using this method with the negative inside here. Now, where do we get the b and the a from? We get them from the standard form. And in this standard form, the a will be equal to 3. Not because it is the first value, but because it is a coefficient of the x squared. So a is always a coefficient of the x squared, the number in front of the x squared. Alright, so in this case, the a is equal to 3. And then b, the b is a coefficient of the x. And so the b is this value right here. That is the b, the number in front of the x. Coefficient of the x is always a b. Notice I've included the negative sign in it. So it's not just 8, it is actually negative 8. So the b is negative 8. And then the c is the constant term in the expression, which is that positive 2 or just 2. So the c in this case is 2. I'm going to be using this a, b, and c to calculate these. And to calculate the first one that we want, the xt, this is the formula that you must know. Alright? And so now it's just a matter of putting in those values carefully. So it's going to be equal to, I'm writing down this minus here first. I'm writing down that minus first. And then the b is negative 8. So I have to put negative 8 there. That's a minus minus. Now I can put this negative 8 in a bracket if I want, or I can leave it like that. But what I know is that minus minus gives us a plus. And then I'm dividing this by 2 times a. That's 2 times this a value up here is a 3. So therefore I'm dividing this by 2 times 3. All I'm doing, I'm working out the value that is to come here in the vertex form. Alright? Now this becomes a positive 8 divided by 2 times 3 is 6. Now some persons left it like that. But in CSEC maths, you're expected to simplify expressions every time it can be simplified. And this can be simplified because I can divide 2 into this and get 4. And I can divide 2 into this and get 3. So the simplified version of that is 4 and 3. 4 over 3. So 4 over 3 is the value that is coming here. 4 over 3 is the x value at the turning point on this function. Alright, then we need this value, the y value at the turning point. Let's work it out here. So the y value at the turning point formula is 4ac minus b squared divided by 4a. Again, this is a formula that you need to know if you're using the formula method. Alright, there are other ways to do this work or to do this task, but I'm using this calculation method, this formula method to do it. So now it's a matter of placing the same a, b, and c in the correct place on this formula. Alright, so let's be careful. And so it's 4 times a, and again the a is this 3, so that becomes 4 times 3. Times c, and the c is this 2. So I'm multiplying by another 2. Then it's minus, I'm putting down that minus. Remember now, this minus is not under the square. So it's going to stay minus. And then I'm going to square the b, and the b is negative 8. So I'm putting negative 8 in a bracket, and I'm squaring it. And then I'm dividing by 4 times a. 4 times a. Again, the a value is this 3 right here. So that is 4 times 3. Then it's a matter of simplifying this down to get my yt value. So let's put it here. The yt value then becomes 4 times 3 is 12, times 2 is 24. So this whole expression here becomes 24. This minus stays a minus. It doesn't change because it's not being squared. So it stays minus. So I subtract. And then this negative 8 squared means negative 8 times negative 8. When you multiply a negative number by a negative number, it becomes positive. Or when you square a negative number, it becomes positive. And the 8 squared is actually 64. So this whole thing here becomes 64. Then I'm dividing this by 4 times 3 is 12. Then 24 minus 64 is a negative number, negative 40, because I'm subtracting a large number from a smaller number, so it becomes negative. That's negative 40. And divide that by this 12. And then this can be simplified as well, because this is a multiple of 4 and this is a multiple of 4. So my yt value then becomes, if I divide this by 4, it becomes negative 10. If I divide this by 4, it becomes 3. And so this is my y value at the turning point. That's going to go here. Alright, so I have my two values, and I also know that the a is this 3. It means then that I can write this expression now for g of x. Alright, g of x. I can now write it down here and put it in this form that they wanted. The question wanted us to put it in that form. So the g of x then becomes equal to the a is 3, and it's x minus, and the xt value is 4 over 3. Don't forget to put on the square, and then the plus yt is negative 10 over 3. Now some persons will put plus negative 10 over 3, but we can still just put minus 10 over 3, because plus times minus will be equal to minus. Alright, and so that is it. So we have written this now in the form a into x plus h squared plus k. We have written it in that form. Let me change the color of this. Let me change the color of this thing. That's what they told us to write it. They told us to write it in that form. Let's change it to red. Alright? And what it means, if we were to write down the values, I didn't bother anybody with the question, with this part of it. And the question did say we have to state the value for E, H, and K. Right? So I didn't bother you in the class because normally they don't ask for that. But writing the value for E, H, and K is a matter of comparing this with this. Now the A is clearly going to be 3 if we're going to write down the values. The plus H is minus 4 over 3. So where they have a plus H, we now have a minus 4 over 3. And plus H, you don't have to put the plus on it. Or if you write it this way, plus H is minus 4 over 3 when you make that comparison. But as I said, you don't need to put on this plus. I'm going to take it off. Alright? And then this plus K is minus 10 over 3. So we could write plus K is minus 10 over 3. And again, we don't need to put on that plus. And so the K is minus 10 over 3. So if you're writing the values, A, H, and K, that is what they would be. Alright? Now let's just remind ourselves of something. Let's remind ourselves that the standard form up here tells us two things about the quadratic function. The A value tells us the shape. Because it is positive, we know that the shape of the quadratic function is that it will smile on a graph. And the C value here is where it crosses the y-axis. That's what the standard form tells us. Because on the y-axis, this x value will be 0 and this x value will be 0. And so the y value will be 2 on the y-axis. So the C is always the y-axis intercept. And then this vertex form that we have, which we have concluded down here, this value here is the x value at the turning point, and this value is the y value at the turning point. So the vertex form that we have created here tells us about the turning point on the graph. Alright? Turning point. Let's continue to answer the other parts of this question. So part 2 is asking us to state whether the function has a maximum or a minimum. It's going to be that it has a minimum, because once the A is positive up here in the standard form, the graph is going to have a smile shape, meaning it's going to have a minimum value, a minimum point. Alright? A minimum point is where you have that minimum value. So, part 2, state whether it has a maximum or minimum value. We're going to say g of x has a maximum value, and g of x has a minimum value. So, part 2 states whether it has a maximum or minimum value. We're going to say g of x has a maximum or minimum value. So, part 2 states whether it has a maximum or minimum value. We're going to say g of x has a maximum or minimum value. a minimum value. And g of x is this whole function, you know, guys. What it is that we have to accept and understand that the function is giving us y values. So a function value is a y value, because you input x values inside here, do this calculation, and the result is a y value. The result is a y value. So the function values are y values. We need to understand that. So the question asks us now to state that maximum or minimum value, and we know now it's a minimum, so I can cross out this word maximum. We know it's a minimum, so I can cross this out as well. We know it's a minimum because the a is positive. That's why it's a minimum. All right, when the a is positive, the vertex value or the function has a minimum value, and the vertex point is a minimum point, having a minimum value. So when it asks us for this to state the minimum value of g of x, it is asking us for the y value at that turning point, at that vertex point. The function value is a y value. We need to understand that, a y value. The value that you get out of the function are y values. Right? So for this one, the minimum value is the y value at the turning point. So the minimum value of g of x, the function g of x, is the y value at the turning point. And what is the y value at the turning point? It is this value that we calculated here, the yt value, across out some stuff. This minus 10 over 3 is the minimum value, the y value at the turning point. See, it is negative 10 over 3, the y value at the turning point. Negative 10 over 3. Some person is giving the x value at the turning point, which is wrong for the minimum value. And some person is giving the point. The question didn't ask us for the minimum point. This is the minimum value. If they wanted the minimum point, you have to put the coordinates and just write it out for you. The minimum point. You have to put the x and the y value in there is xt, yt. That's a minimum point on the graph, not the minimum value. The minimum value is the y value at the turning point, the lowest y value on the graph. You have to make the distinction, everything important. Mathematics is the most exact science. There's a difference between minimum value and minimum point. The minimum point is referring to the coordinates of the point. In this case, would be 4 over 3, negative 10 over 3. That's your minimum point. And at that minimum point, the y value at that minimum point is your minimum value of the function, because remember, the function is giving you y values. So when the question asks you for the minimum value, it's asking you for a y value. All right? Then part 3 now is going to bring in now the x value at that point, which is this one, now, part 4. This part. Again, we know it's minimum, so we can cross out this word maximum. So it's saying state the value of x at which g of x is minimum. In other words, what is the value of x that will make g of x have that minimum y value? That value of x is the xt value, the value of the x value at the turning point. All right, so part 4, let me emphasize that a little bit more. So part 4 is that the minimum value of g of x, which we know is this one right here, occurs when the x value becomes equal to the x value at the turning point. That is when the x value equals 4 over 3. Let me prove it here now, and so we can kind of get a clear understanding of it. Now remember that the function in the vertex form is this. I'm going to copy it down. What's happening here? I want to copy all of this. Right. Let me just copy it down just to emphasize this what the question is asking us. All right. So let's start look at this function right here now. Now, question says what value of x is going to give us this minimum value? It is the value of x that will make this part become 0. Then the y value becomes that. So look at it carefully. It is when this value of x becomes equal to this xt value. Because when that value of x becomes what this is, we're going to have 3 into 4 over 3 when the x value becomes equal to the xt value minus 4 over 3 squared minus 10 over 3. What happens? This in here becomes 0 because 4 over 3 minus 4 over 3 is 0. And when this in here becomes 0, everything here disappears, becomes 0. And your g of x value becomes 3 times 0 squared minus 10 over 3, in which this is 0. So you're left with g of x equal negative 10 over 3. So the question is asking you here, what value of x will make g of x negative 10 over 3, where negative 10 over 3 is that minimum value? That value of x is when the x equals the xt value. And that is why this is the answer. When x equals the xt value, that is when g of x becomes the minimum value of negative 10 over 3. But I understand that? I'm here talking. It's not a monologue in this.
Yes, sir.
Good.
Yes, sir.
Yes, sir.
Beautiful.
Yes,
So I want us to understand these minute differences and know what they're asking us. If they're asking for a minimum value or a maximum value, that's a y value. Because the function produces y values. And what it is that you're giving the function x values, and then the function is calculating those y values for you. So the function values are y values. So once the question says, what is the minimum value of the function? It's a y value it's asking you for. And here it's clearly asking you for x value. State the value of x. It's asking you for x value. That value of x is the x value at the turning point. Right? It's the x value at the turning point. And I always like to say the x value and the xt value and the yt value, they go together. They are at the same point on the graph, at that vertex point. Whether that vertex point is a minimum or a maximum. Just that in this case it's minimum because the a is positive. And we show that with a live graph one day. We will actually plot points on a graph and we show that if the x squared term is negative, the graph will frown. And if the x squared term is positive, the graph will smile. We did that in the class, right? But we need to get to a stage where we just know that that is what will happen. We just know that is the knowledge base. That is what gives you your knowledge marks on an exam paper. Remember the profile on the exam paper is knowledge, understanding, and the ability to compute, to calculate. So there are certain things that you must know, then there are things that you will understand, and there are things that you are able to calculate. That's why the profile is set up like that. There are things that you absolutely must know. You know them and then you apply them. All right? So that finishes that part, guys. So the x value at the turning point is the value of x that will make the function minimum, make the function of a minimum value. Remember, if the question asks for the minimum point, this would be an answer. So in the word that I sent in the group, I see some person giving me the minimum point as the minimum value. No. Minimum point is a point having an x value and a y value. If I ask for the minimum value, it's just this. If I ask for the value of x, for which a function is minimum, it is just this. That's the value of x. Alright. Alright, you're going to have the video that you can watch back and listen to me say these things over again. Get it right. We're moving on to something new from tomorrow, guys. So we have to get this right. Get this clear understanding of these things. Alright? And then we're going to look at some past papers and put it all together. But the next part of the question is for us to sketch a graph. Sketch a graph of the function, right? That's what this part is about. right? Sketch a graph of the function, and they're telling us what we must show, right? They want us to show the y-axis intercept, they want us to show the location and coordinates of that turning point, which in this case are minimum. They want us to show the axis of symmetry, because quadratic graphs will always have an axis of symmetry, because a parabolic graph having a parabolic shape. And they also want us to show the position of the roots. And why I would say position only is because we have not yet done the portion of quadratics where we're calculating the value of the roots, or the values of the roots. All right. So we want to make a sketch of this graph. Now, there are critical things about this graph that we must show. All right. Now remember, the graph will either smile or frown. We know that this one smiles because the A is positive. So since the A is equal to 3, which is a positive value, we know that the graph is going to have a smile shape. And when it has a smile shape, it means that going from left to right, it comes down to a minimum point and then it starts going back up again. All right, so when it smiles, it has a minimum point, and that minimum point is a turning point, and we calculate the coordinates of that turning point, which is xt, yt. Remember, the t means turning point in this expression, guys, and the x means x value. So this is x value at the turning point. The y here means y value. This is y value at the turning point. The same value we calculated up top, and that's 4/3 negative 10/3. This is the critical information we need. The other piece of information that we need, right, is what right here, the y-axis intercept. I will get that from the C value in the standard form. The C value in the standard form tells us where the graph crosses the y-axis, which is called a y-axis intercept. All right. So the
But
C value
how
in this
does
case is
your name?
That's a question. Somebody asking a question?
No, sir.
Okay, all right, mute your mic. Mute your mic. All right, so remember now, the C value tells us the y-axis intercept. So because the C value is 2, it means that 0C, which would work out to 0, 2, becomes your y-axis intercept. And all we need to do now is sketch a graph to reflect the smile that we get from the A, the minimum point xt, yt, and the y-axis intercept. And we have to put them in the right place. It's just a sketch, so there's no need for absolute accuracy in terms of a scale, because it's just a sketch we're doing. So we're not going for 100% accuracy. We just need to ensure that the graph has the right shape, it turns in the right quadrant, and crosses the y-axis in the right place, on the right side of the y-axis, whether it be the positive side or the negative side. Let's read it out again. So we're going to do the sketch right here. So I'm going to put in the y-axis and put in the x-axis, just a sketch. And let me do the sketch in a different color, in purple. All right. So we know that the graph is going to have a smile shape, right? But we don't know where it turns. Does it turn there? Is it turning there? Is it turning there? Is it turning down here? Is it turning on the x-axis? Is it turning to the origin? Everything important. We know that it turns at this point. This point is where the x value is positive and the y value is negative. Where on the graph would the x value be positive and the y value negative? Let's look at it. X values are positive to the right of the y-axis. That's a positive x value. And y values are negative down here. Negative y values. It means that this point, which has a positive x value and a negative y value, is located somewhere down here. So the graph must turn somewhere in that quadrant of the graph. Right? The curve. The quadratic curve must turn somewhere in this quadrant down here. Down here has positive x values and negative y values. Up here has positive x values and positive y values. That's not what we have. Over here has negative x values and positive y values. Down here has negative x values and negative y values. We want the quadrant with a positive x and a negative y. That is down here. So we know that the turning point is somewhere down here. And it doesn't matter exactly, we don't have an exact place to put it because we're doing a sketch. So we know it's going to turn down somewhere down here. The turning point is somewhere down here. Then we're looking for 0, 2. That's a positive y-axis intercept. 0, 2, where it crosses the y-axis. That's the point where it crosses the y-axis. That's a positive y value on the y-axis. Positive y values on the y-axis are somewhere up here. Right here is 0 y value. Up here is positive y value. Down here is negative y value. So we want the part of the graph. We want the part of the y-axis that is positive up here. So the curve that we are drawing must smile. It must smile. It must turn down here and it must cross the y-axis up here. And that's all we have to do, just draw that. A smile that turns down here and crosses up here. So just draw it like that. That's it. Right? See, it crosses somewhere up here and it turns down here, the red. So let me take these out now. That's the sketch. Right? That's a sketch. That's good enough. A smile that turns down here and crosses up here. Then all you have to do is label it up. So this point here is the y-axis intercept. Exactly on the point where it crosses the y-axis. As some people think up here, for example, which is wrong. It has to be the point where the graph intersects the y-axis right there. So that is the point 0, 2, the y-axis intercept. And then the lowest point on the graph down here, some people putting it here, which is wrong. You have to put it at the absolute lowest point on the graph, right here. That is the 4/3 minus 10/3 turning point on this graph of g of x. This is the graph of g of x. That's what we have so far. The y-axis intercept and the minimum turning point. Then the question asks us to show the axis of symmetry or the line of symmetry. And I see some people drawing it beside the minimum point. No, that is wrong. And some people drawing it slant like that. That is wrong. It's a line that is vertical like the y-axis. And it passes exactly through the vertex point. Everything important. So I have to draw a vertical line that is parallel to the y-axis through here. That is it. And then we have to label it correctly. Some people know that it is x equals the xt value. So it's the axis of symmetry. Some people doing this. Let me shift this down. Let me shift all of this down a little bit. So some people doing this. Axis of symmetry, and I put equal 4/3. Can't do that, that's wrong. The axis of symmetry, line of symmetry as an equation, x equals a number. You have to put it exactly like that. X equals the number. What number? The y-axis intersect the x value at the turning point, sorry. The x value at the turning point. Vertical lines will always have an equation. X equals some number. What number? The x value at a point that it passes through, which is the x value turning point. So it's x equals 4/3. This thing here is the equation of the axis of symmetry written like that. X equals 4/3. You can't just put on 4/3. You have to write out this is equation. That is the equation of that vertical purple line. X equals 4/3. The y-axis has an equation similar, you know, the y-axis. Equation of the y-axis is x equals 0, you know. That's the equation of this line, you know, the y-axis, you know. X equals 0. This is the actual equation of the y-axis, you know. X equals 0, you know. And all vertical lines would have an equation looking that similar way. X equals some number, you know. Right? So for example, if I put a vertical line up here, use a different color, just to emphasize the point. If I put a vertical line up here, and it pass through 2 on the x-axis, then this line is x equals 2, that black line. If it pass through 2 on the x-axis, it's x equals 2. And then horizontal lines have an equation, y equals a number. Right? So the x-axis is actually y equals 0. That's the equation of this horizontal x-axis. So if I were to draw a horizontal line through this point where the y value is 2, like this, horizontal, like the x-axis, then the equation of this black line right now is y equals 2. That's the equation of that horizontal black line. So horizontal lines carry an equation y equals a number. And remember that, just remember that the x-axis is y equals 0. So horizontal lines, like the x-axis, would be y equals a number. Alright? So I'm just trying to say all of that to emphasize the point that that vertical line actually has this equation right here. This equation right here. And then that was the sketch, guys. And that was the end of the question. Everybody understand? Everybody good? Everybody have anything to ask?
No,
sir.
No, sir.
Very good.
No, sir.
Beautiful. So let's put what we learn now to apply it to a question now that I sent in the group. Alright? And hopefully by the end of it, alright, you will be clear on some more things. It is progress before perfection. We're not gonna understand everything all at once. Right? It is progress before perfection. So understand a little bit more each time. And that's why I have to keep practicing. The more you practice, the more you gain more understanding. And then eventually, you improve so much, you reach perfection. Meaning, anyhow they set the question, any way they set that question, you'll be able to do it. Alright? So I'm giving you a question that is set out a little differently now. But it's still a quadratic question, and it still relates to what we are doing. And this is it. Question that I sent in the group. This is from the July 2021 exam paper. It's a past paper question. Alright? And this is the question right here. It's a quadratic question on the screen. A lot of persons gave some solutions. Pretty good, but some things to clean up on. Right? We're not quite at perfection yet. We're making progress, but want to attain perfection. Alright, so this question gave us this function, right? And it gave us the table. So it's giving us the values. That's actually worked out all the values for us. And you're going to see on some exam paper where they don't work out all the values for you. What they might do is leave a couple of them. It might give you 4, and you have to work out 3 or 4 for yourself. But in this case, they give us all the values. Now I want to point out something to you on this table. The symmetric nature of the quadratic function. It is symmetrical on the graph in that there's a line of symmetry that passes through the vertex. It's such that the y values on either side of that axis of symmetry is the same distance from the axis of symmetry, from the line of symmetry, the y values. Alright? So you can actually look at this graph and get an idea of where the axis of symmetry is in terms of a value. Now, everybody do it so far actually calculated it from the function. They calculate the xt from this, and they calculate the yt from that. But I'm going to show you now you can pick it up in the values here as well. So look at this now. Look at these values, how they are symmetrical. So you have a -4 and -4 going outwards. Then you come to a -2 and go, if you go further out, you come to another -2. Look at it now. You go outwards from here, you reach -2. Same distance from here, you reach -2. From this line, your line of symmetry will correspond to this point in the table. I'm telling you that now. Look at the values. If you go further out, 3 spaces from this line, you reach 2. Go this way, reach 2 the other way. Right? And if I go further out from this red line, I reach 8 this way. If I go the same distance this way, I reach 8. Right? Now, how I know it's the same distance? Because the interval on the x-axis is 1. So each time. So this is 1 unit, 2 units, 3 units, 4 units from this red line. So the same distance from the red line horizontally, taking it to the same y values. So it means that my axis of symmetry on the graph, or my line of symmetry on the graph, corresponds to this red line right now. Look at it now, that red line. Now that red line would be where the vertex on the graph is. If you sketch a graph, it will be where the vertex is. This red line corresponds to that vertex, correspond to one another. All right? Your minimum point is right here. So the minimum point will be on this red line. Your minimum point, your xt, yt would correspond to that where that red line is. It is right halfway between these two x values. That red line is halfway between those two x values. Between -1 and 0. Those are two x values. See there, these are two x values. That red line is right in between those two x values. -1 and 0. Halfway between -1 and 0 has to be, let me put it up here, -0.5. But I can appreciate that. Halfway between 0 and -1 is -0.5. Can I appreciate that, students?
Yes, sir.
Yes, sir. Yes, sir.
Good. So without calculating xt, I could know that this is the x value of the turning point, you know. Because the turning point is on the line of symmetry, on the axis of symmetry, and this red line represents the line of symmetry based on how these values are symmetrical from it, from left to right, from the line, from that red line, right? And then now the question is, what would be, so this would be the x value of the turning point, you know, by just taking the symmetry of it, and I know it's halfway between these two x values. So my x value at the turning point would be -0.5. I could average these two. -1 plus 0 over 2, giving you a -half, which is -0.5. So I know that my axis of symmetry, I told you I would show you other ways to calculate xt. I told you this is one other way that you could do it. Alright? That's one other way you could do it. By just picking up where the symmetry of the values are. That's my xt value. If you calculate xt the other way, then with the minus b over 2a on this function, you're going to get the same thing, which we will do. But then now the yt value, what will be the y value in down here? What will be the y value on this red line down here? That's the yt value, you know. Y value turning point, you know. So if I use this xt value on this function to calculate the y value down here, that's my yt value. So I can calculate the yt value from the xt value. So my yt, I'm going to do it here. Right here. My yt value, the y value turning point, would be equal to, plug the -half in the function and see what it is. So it will be -0.5, -0.5, let me zoom up. It will be -0.5 squared, that's right here, plus -0.5, that's right here, and then -4. No, not here, then -4. And if you work this out, you're gonna get -4.25, or negative 4, yeah, -4.25. We're gonna get -4.25, -4.25, by plugging in the xt value into the function. We have calculated the yt value. By xt and yt is at the same point. Alright, so I'm showing you could get them that way. But we could calculate it using xt formula, yt formula, just the same, because in this function, look at it, this function, the a is equal to 1, the b is equal to 1, and the c is equal to -4. So this is just, I'm going to show you the way that we learned in class to do it now, the formula way. But I'm making the relationship, showing you that you can actually deduce some of it as well. So the a is equal to 1 because the coefficient of x squared would be 1. The b is equal to 1 because the coefficient of x would be 1. And the c is a constant term, which is -4. So let's calculate it now and see, we're going to get the same 0.5, -0.5, and -4.25 as my yt value. Right? So my xt value, just doing it over here. My xt value will be minus b over 2a. I don't start do the question, I'm just showing you some analysis that you could make. Which will be minus, the b is 1. So it's minus 1 over 2 times a, and the a is 1. That's minus 1 over 2, you know. That's minus 1 over 2. And minus 1 over 2 is negative 0.5. Minus 1 over 2. I need a new pen. So the xt value by calculation is minus 0.5. Now everything must be consistent. Your graph, your calculations, your table, everything must be consistent with one another. Your calculation can't give you one value and your table giving you a different value, and your graph giving you a different value. Everything must be consistent. And if we were to calculate the yt value using the formula method, which is 4ac minus b squared divided by 4a, and plug in the values there, it will be 4 times the a, which is 1, times the c, which is -4, minus b, and the b is 1, right? 1 squared. And the b up here is 1. Right? And you're dividing this by 4 times a, and the a is 1. So it's 4 times 1. If you simplify this, this becomes -16. -16 minus, this becomes a 1. Minus 1 over 4. So that will become -17 over 4. So -17 over 4 is 4 remainder 1 over 4. So it becomes -4 remainder 1 over 4. If you put that at a decimal, that's -4.25. Alright? So that is it. So same thing we got up here. Doing a quick short way and recognizing, observing that the x value turning point has to be the halfway mark between the 0 and the 1. But this becomes the line of symmetry based on the values down here. That red line becomes the line of symmetry based on the values. And we know that the xt and the yt, the x value on the line of symmetry is the x value at the turning point, and the y value on the line of symmetry is the y value at the turning point. And that's how we did over here, recognizing that that red line represents where the line of symmetry or the axis of symmetry would be. But you could calculate it, the xt, using this method and using that method. But I want you to learn everything and get a full understanding of these things. Alright? But this question says now, you have to write down the maximum and minimum value of a function. It is this value right here. A lot of persons put -4. Right? A lot of persons put -4. Now, -4 cannot be the minimum value. Even though it's the lowest value in the table, it cannot be the minimum value of this function. You must know that the minimum value occurs at one point only. So -4 cannot be the minimum value because that's at 2 different points. The minimum value occurs at a vertex. The function only has one vertex. The minimum point is at that vertex only. So the minimum value is on that red line that I've drawn. So -4 cannot be the minimum value, guys, because it's that minimum. -4 is at 2 different points. And the minimum value can only occur at a single point only, at the vertex point only. One point at the vertex point. So it cannot be -4. Right? It has to be the y value on this red line. So you see, this question is testing your knowledge, you know. So you would have to know, you have to either work out yt and get the -4 and a quarter, or the negative 4.25, you have to calculate the YT and don't put negative 4. Or do it up here and recognize that it has to be on this red line. And it is the x value on the red line is this. And so you plug that x value on the red line into the function to get what the y value is on that red line. So in any case, the minimum value is the lowest y value on the graph, which is the YT value down here, negative 4.25. Any way you want to calculate it. So it's the YT value, which is negative 4.25 or negative 4.25, or if you want to put negative 17 over 4. Any way you calculate, I've shown you 2 ways to do it. Everybody okay with that?
Yes.
Okay?
Yes, sir.
Yes,
And
sir.
it's a
Yes,
minimum, it's
sir.
a maximum or a minimum. I'm gonna say it's a minimum. It's actually a minimum. Why when it's a minimum? Because the squared term is positive. So the graph is gonna have a smile shape. It's not a maximum, it's a minimum. So it's also good to state that it's a minimum. And this is it. And some persons did this. Some persons recognize that we get the 0.5 for the third and negative 4.25. This is wrong. That's not a minimum value. That's a minimum point. If the question change this word and put point, then the answer would be this. But then they ask us for minimum point. They ask us for minimum value, which is a y value. So this down here is wrong for this question. It didn't ask for minimum point. It asked for minimum value. You do another question that will ask for minimum point, you know. So there's another question that will ask for the minimum point, and you put it in a bracket, and you will give the xt value and the yt value as your minimum point. Different thing that. Answer the question. Everything important. Mathematics is the most exact science. So if the question says point, you give them point. If they say minimum value, you give them value. If they ask for a value of x, you give them a value of x. If they ask for a value of a function, value of a function is a y value. So you must be giving them a y value. If the question asks for values, plural, it means more than one. So you're looking for more than just one value. So pay attention, everything important. All right. So that is it. That's the first part. Everybody understand this first part? So I can move on.
Yes, sir.
Everybody good with this
Yes.
first part? Good. The next part now says use a ruler, draw the axis of symmetry on the graph. You have to know the axis of symmetry corresponds to where it crosses right in the vertex there. Right halfway between the correspond to where that red line is. Right? And it pass through the axis of symmetry pass through the vertex XTYT. So the axis of symmetry passes through the vertex XTYT, which is negative 0.5, negative 4.25. Alright? So this is it, and them must draw it, right? Them say sketch the graph. Or them must draw the graph up here. We didn't draw the graph yet. So I didn't draw the graph yet. So we have to plot these points and draw the graph. And then we have to put on. So the important thing is that with plotting this graph, guys, so listen good now. The important thing is plotting this graph is that the table did not show you the vertex. It did not show this point. It did not show this point. The graph did not show this additional point. It left it off. You have to figure it out. 0.5, negative 0.5, negative 4.25. That's a point that you're gonna have to add to the graph and show the graph passing through that point. You're gonna have to add that point, that vertex point to the graph and draw the graph through it as well. They didn't give it to you in the table. Some questions the vertex point will be in the table. This question it is not in the table, but you must know that a vertex point exists on a quadratic function and know how to find it and add it to the graph. And especially know that down here they ask you for the axis of symmetry. you have to draw that axis of symmetry through that vertex point that was not on the table, that you have to figure out and add it to the graph. That's the level of the knowledge. That's how the knowledge comes in now. The knowledge comes into this question. And by you adding this point to the graph, that is demonstrating your knowledge, and you will get the knowledge marks for adding this point to the graph. Even though it is not a point in the table, you must know that that point exists on this function and add it. So let's go down here now. So notice they gave us half of the values. They gave us the other half. So after adding the other half, all right? So this is the minus half line, this line, This is x equal minus half line. That's axis, Sorry. The axis is on, this is the axis of symmetry, I don't even draw the graph, but I know this is the line x equal minus 0.5 right here. Remember, the axis is between 0 and negative 1 in the table. Between the x values of 0 and negative 1. That's where the axis is, that red line, where the values are symmetrical about that red line. That's where the axis is. Right? So, it's that red line that I'm putting in now, right between the 0 and the negative 1. This is the axis of symmetry on the graph. Without even drawing the graph, this is it. Right? This is negative 4 and the other negative 4. Remember, there's a point here on the graph. Let me put them on in blue, the other points. There's a point here, 0, negative 4. Right? 0, negative 4. Right here. Then you have 1, negative 2. So you can know, that there's a point, the same distance from the axis to this point. There's another point, the same distance over from the axis over here, Right here, same distance. See? From the axis. Same distance from the axis. 1, 2, 3 units to the axis to get to that point. So 1, 2, 3 to get to another point on the graph. Because the points are symmetrical about the axis of symmetry. So there's a point right here. 1, negative 2. Without looking at the table, there's a point there. And just as though, if I continue up here with this axis of symmetry, look again. If I continue up here with this axis of symmetry, I can count off how many points, how many units to this point over here. 1, 2, 3, 4, 5 units to this point from the axis. So there's a point, and there's a point across from the axis, same distance from the axis to this one. So I can count it out. 1, 2, 3, 4, 5 units. There's a point right here. Correspond to that one. This red line is a mirror image between these 2 points. Is a mirror line between those 2 points. So this point was what? 2, 2. Let's see if that is true. 2, 2. See there? 2, 2. There's a point 2, 2. And without looking at the table, I can still figure out the next one as well. Look. Because I identify the axis of symmetry, the red line. Let me take these out. I want us to have this full understanding, so we're not just working blind. Right? So this is axis of symmetry. And we have this point on this side of the axis of symmetry. How far is it from the axis of symmetry? 1, 2, 3, 4, 5, 6, 7. So there's a point 7 units on the right of the axis of symmetry. 1, 2, 3, 4, 5, 6, 7 right here. There's a point right there. What point is that? That point is 3, 8. I bet there's a 3, 8 in the table. See there's a 3, 8 in the table. So I could put in those points just by identifying the axis. I know that there are image points same distance on the other side of the axis of symmetry. Then know the point that you must add to this guy. Let me put on in purple for you. Is the point negative 0.5, negative 0.5, negative 4.25. I have to add that point to the graph. Some process drawing the graph, right? Some persons drawing this graph and they come down here, come through here, and then they go straight across here. And then they continue. This is wrong. You cannot go straight across there. There is no straight line on a quadratic graph. You cannot just go straight across here. You have to know that it continues down to a minimum point and then goes back up. So we need to identify where negative 4.25 would be. Let's estimate where negative 4.25 would be. Somewhere below this line, somewhere below that line. That is negative 4. Let's look at the scale. Let's scale it, zoom it up and look at it. Mathematics is the most exact science. On a graph, you want to be accurate. You want to be accurate on a graph. All right. So watch this now. This is negative 3, that's negative 4. So right here will be negative 5. So halfway between the negative 4 and the negative 5 will be negative 4.5 right here. Will be negative 4.5 right here. But I can argue with that. I'm trying to locate 4.25. Negative 4.5 is halfway between negative 4 and negative 5. But I can argue with that. But I can argue with that.
Yes, sir.
Yes, sir. Yes, sir.
And then halfway between negative 4 line and negative 4.5 line is negative 4.25. So somewhere inside here, almost around here, is negative 4.25. And it is on this red line. The point is, so we're talking about somewhere about here is a minimum point. Somewhere about there, so is a minimum point. Somewhere there, so this point is negative 0.5, negative 4.25. That is your vertex right there. And I'm in the exam, I'm putting it like this and label it like that. May the examiner see it because I want my marks. So I'm going to take these out now. I put these in just to estimate where it was. Remember, we have a point here on the graph as well, right here. This point is a point on the graph, 0, negative 4. Is a point on the graph, 0, negative 4. See there? 0, negative 4. Is a point on the graph. So those are the points. You have to make a graph come through this point right here. And say, I label it, make him say. The examiner said, that's my minimum point. See? That's my minimum point. Minimum point. And I can draw the graph now. I put in the axis already. No problem. I put it in before or after they told me. So I'm going to draw the graph now. Smooth curve through the points, right? Draw a smooth curve through the points. And you make sure you come down to this point down here. And then you go back up. Make sure you come down to that minimum point. And then you go back up. Through these other points. Do that and you get your marks. Let's label the axis of symmetry. Let's label the axis of symmetry. This is vertical red line. A lot of persons got it. Make sure it passes through the minimum point down here that we have labeled. Right? And let me extend it all the way up here so I can label it. So the axis of symmetry is x equals minus 0.5. Or if you want to put minus half, that's okay. Same thing. And that is it. That's a sketch. And let me see what else I wanted. So use a draw the axis of symmetry. So we'll draw it and we'll label it. And the minimum value is this. This is the correct answer for the minimum value. If you ask for the minimum point, it will be this. Because I did not ask for the minimum point. That is it. I think that finishes that question. But okay? But alright?
Yes, sir.
Yes, sir.
Persons who did it and made little mistakes, understand it better?
Yes, sir.
Yes, sir.
Want to make
Yes,
I want
sir.
you to make your, I want you to make your corrections. That is it. When you do the questions, learn from your mistakes. You improve, you understand it better. So it's important for you to actually do the work. Don't worry about getting stuff wrong right now. Right? You want to get stuff right in the exam. Getting stuff wrong now is not a problem. Because you learn from you making your mistakes. Alright. Let's see if we can do another question. So we're going 1 hour now. Let's see if we can finish another question in about half an hour. I don't want this session to be too long. So I sent you another question. Easy, straightforward question. But let's do that one just for good measure. We'll call it a day. I really wanted us to learn some stuff from this particular one. Alright? So the other question that I gave you, somewhere here. Where is it? Right here. This is it. So what I do, guys, I send a couple more questions to the group today. I will keep practicing. We're moving on to something different tomorrow. Alright? So I want to just keep practicing. So this one is a straightforward one, guys. Similar to the one that we did. I think I want to send you a frown one in the group. And what I might do for that one is send it to you soon after the class. You get some practice. And then maybe more than one. And then a little later on, just send you some solutions. And maybe record some messages to you or something. For us to keep the revision going. Alright? I'm moving on to new stuff tomorrow. Alright, look at this one on the screen now. Typical question. Simple, straightforward. It says, write this expression. Write this expression in this form. In other words, they want us to complete the square. And so don't give a lot of space to do it. Alright? There are many ways to do this thing, guys. But I'm not going to use this, as you know. I'm going to use a into x minus xt squared plus yt. I'm going to calculate my xt and my yt. In this standard form, let's write out the a, the b, and the c from now. Let's put it out in red. Square term is positive, so now we're going to have a smile, and the coefficient is 4. So a equals 4. This is the x term. The coefficient is negative 24. So the negative 24 there, number in front of the x, that's the b. So b is negative 24. And the c is a constant term right here. So c is 31. What's some large values they're giving us here? So you have to work with them. Alright, so a equals 4, b equals negative 24, and the c is 31. Alright, let's calculate the xt first. I will put in here the xt. So the xt that we need is minus b divided by 2a. Minus b over 2a. You have to just know this formula, guys. You will be using this method. Alright, so it is equal to minus, that's this minus I wrote down first. Pay attention now, the b now is negative 24. So I have to put negative 24. And I divide that now by 2 times a. That's 2 times this 4 value. 2 times 4. And I gave you this question because I wanted to show you something new that I have not shown you as yet. So this works out to a positive 24. This works out to be 8. 24 divided by 8 is actually 3. So this is the x value at the turning point. So what I really want to show you with this example, guys, is this. There's another way that you can calculate your yt value. And you especially use this other way when your xt value is a whole number as it is now. To get your yt value, all you need to do is take this xt value and plug it for the x into the function. And that will give you your yt value. You don't have to use a formula method to get yt all the time. When you know your xt value, another way to get the yt value is to substitute that xt value back in the function. Because remember now, xt and yt is at the same point, you know. Yt is the y value on the function when the x value is xt. So therefore, you can calculate your yt value by substituting your xt value on the function. So let's do it here. Let's do it here. So I haven't got no xt. We can say and yt is equal to, I'm going to plug the 3 into the function here for the x. I'm going to do it the other way as well just to show you. So it becomes 4 times. 4 times. We're doing this first. 4x squared becomes 4 times 3 squared. Minus 24 times x. We're using 3 for the x. Plus 31. Whatever this works out to will be my xt value. My yt value. Now this is 9. And 9 times 4 is 36. Minus, I think this is what? This is 72. Plus 31. This will work out to what? Negative 5, I think. Because this and this is negative 36. Negative 36 plus 31 is negative 5. That's my yt value. Let's work out yt and using the formula method and see if we get the same negative 5. Let's look at it. So you can see. So yt formula method will be 4ac minus b squared divided by 4a. Let's put in the values now. So it will be 4 times a. The a is 4. The a is 4. Times c. The c is 31. Minus b squared. So subtracting negative 24 squared. And then dividing that by 4 times a, where the a is 4. And I'm not going to waste time over that. I'm going to bring up the calculator and show you that to get negative 5 with the calculator. Let me bring up the calculator and show you. If I do it with the calculator, rather than work out all those big values, I can't bother. Where's my calculator? Here. So I'm going to put these values in the calculator exactly as it appears there. And you're going to get a negative 5. So if you work it down, you're going to get it. I'm going to put these values in the calculator right now. I'll show you this. I'm putting this in the calculator exactly as it is there. So it's a fraction. On the numerator, I have 4 bracket, 4 close bracket, bracket, 31, close bracket, minus, open bracket, negative 24, close bracket, squared, divided by 4 bracket, 4 close bracket. See that? Negative 5. Look down on the answer part of the calculator there. You say negative 5. But you can see that? So this works out to negative 5 as well. If you were to work this out and simplify, you're going to get negative 5. So I've just made a little bit of progress with you guys. I deliberately did not show you this way in the class because I wanted to understand the formula way first. So I'm showing you that especially when your xt value is a whole number, you can calculate your yt by the substituting that whole number xt value for the x in the function, and you can get your yt value that other way as well. But go to that. But okay?
Yes, sir.
Good.
Yes, sir.
It means that this expression written in this vertex form, where we're using this xt format up here, will be the a, which is 4. I'm just writing it under here. Bracket. X minus, and the xt's are 3. Don't forget to put on the square. And the plus yt is negative 5. Minus 5. So this is what I'm putting in the box is the answer for this question. I just wanted to use this opportunity to show you that you can calculate yt another way, especially when the xt is a whole number. But I get that. But I get that?
Yes, sir.
All right.
Yeah.
The next part now wants us to make the sketch. Wants us to make the sketch. Now, to make the sketch, let's do the analysis. It's gonna smile or frown. Smile or frown. It's gonna smile because the A is positive, right? So now we have to do a smile. Next thing, what's the y-axis intercept? What's the y-axis intercept on this graph? 0C. 0C. Remember it's 0C.
Sure, so we're not back there.
031. 031. Good?
Yes, sir.
Good? And then the minimum point is xt, yt. In this case, it is 3, -5, don't it? So the turning point is at 3, -5. And then basically put on a scale for us. Let's sketch it out in blue. So we're sketching a smile that crosses axis here and that turns here. That's what we're sketching. So we know that it smiles. But where would this point be? This point is going to be somewhere in this quadrant, don't it? 3, -5.
Yes, sir.
Right? 3, -5 puts us somewhere down here. And then the 0, 31 is going to be somewhere up here. But see that? So that's what we want. We want our smile to turn down here and cross up here. And all we have to do now is draw it. Let's draw it in purple. Let's draw it again. That's all CSEC wants it to do. I'll take this out. And then label it up. So right here is this minimum point, 3, -5. And this y-axis intercept is 0, 31. That's what the question wanted right here. Let me take this off so you can see it. That's what it wanted right here in this instruction. It says, on the axis below, sketch the graph of this, indicating the coordinates of the maximum or minimum point. We know it's a minimum, and the y-intercept. That's what they wanted, the y-intercept and the minimum point. So guys, you see that the same thing I asked you to do in the class, the same thing you've seen on past papers. And as I always say, if that is the case, and you can do it in the class, then you can do it in the exam room. Because the same thing I ask you to do in the class is the same thing you see them asking here on exam paper. Now, this exam paper is January 2024. Very, very recent. Just the other day. Last year, January. So if you can do it in the classroom, you can do it in the exam room. There's no need for you to get nervous or be afraid or to feel that you're doing the wrong thing. Anything you can do in the classroom, you can do it in the exam room. So this is how now we start to build confidence. Build confidence. Do exam level work in the classroom. Do exam level work in the exam room. Anything you do in the classroom and get right, do it in the exam room and get right. Notice, guys, this is the exact same thing been asking you to do in the classroom. And now you see it on actual exam paper. You do it right in the classroom and you get it right. You do it in the classroom and you get it right. So there's no need to get it wrong in an exam room. There's no need to be nervous or be fearful of these questions in an exam room. You are doing exam level work in the classroom. So you know that you will be able to do the same kind of work in the exam room. Alright? So I just wanted to show you this. This one says we have to state the equation of axis of symmetry. Same thing I asked you in the exam, in the classroom. State the equation of the axis of symmetry. And as I said to you, we know this will be the axis of symmetry. If I put on a graph, a vertical line passing through here. Axis of symmetry. And you know it's x value turning point. You cannot put equal 3. Down here, you cannot put 3. You have to write x equals 3. X equals the x value at the turning point. 3. 1 mark for it. If you put 3, you're not getting the 1 mark. Because that's not an equation of any line. And you cannot put this either. You cannot put x equals xt. Why? Because you know what xt is. You know that it is 3. So put the correct thing and get the 1 mark and go about your business. X equals 3. This is what you have to put. Anything other than that, you're going to lose the 1 mark. And CSEC don't give half mark. Is that you're right or you're wrong? But understand that everything important. Everything is important, guys. I see some people ask people for the axis of symmetry and the right tree. No. It's an equation they're asking you for. So the word equation there. Equation. It is x equals 3. This full thing is the equation of the axis of symmetry. X equals 3. Anything other than that, you're not getting this 1 mark. I want the 1 mark. 1 mark can be the difference between a grade 1 and a grade 2. It don't make sense to give away a 1 mark like this by not paying attention to the details. Everything is important. The way you write it is important. And remain consistent with it. Don't bother improvise. Don't bother be creative. Don't reinvent the wheel. Just do it the right way, the same way every time. X equals whatever the x value is at the turning point. Put that together and that becomes the equation of that vertical red line that passes through the turning point. That is the line of symmetry or the axis of symmetry. Right? We saw in the graph a while ago that the points on the graph are equidistant from the line of symmetry. Right? What it is that this half of the graph is a mirror image of this half about this mirror line. That's like a mirror line in the graph. That's why it's a line of symmetry or an axis of symmetry. But I understand that. Body good? Body
Yes,
okay?
sir. Yes, sir.
Feeling better about this topic?
Yes, sir.
Good. Alright, so we need to keep it that way. And to keep it that way, you have to keep practicing. So when I send more questions to the group today, you have to do them. And don't bother with the foolishness. Do the questions. Because we want to master these things. These are the questions coming on exam paper. It don't make no sense we get them wrong. When we expose to them from now. Expose to them in the classroom. Expose to them in the revision. When you see them in the exam room, you kill them. Get them right. And get the full marks for them. No bother no foolishness. Get the full marks for them. Collect your marks and go about your business in the exam room. And there's no need for fear in an exam room. If you can do it in the classroom, you can do it in the exam room as well. Alright guys, that is it for today in terms of a class today. But we're not finished for today yet, as I'm sending out questions for you to practice. We're moving on to new material today. So we're going past this thing. What we're doing tomorrow will be related to these things. I will not finish with this fully yet. But we're moving to the next level. Tomorrow we're focusing on the roots right here. Focusing on the roots tomorrow. Those points. And we're going to be doing some additional stuff tomorrow as well. Alright guys? So that is it. So when I send out the question today, send them to them and send them back in the group, please. Alright? That is it. But alright now? Body good? I want to end it now.
Yes, sir.
Alright, beautiful. So see you all in class tomorrow and Monday. See you in class tomorrow and Monday, but I'll be sending out questions to the group right about now. Alright, do them and send them back on me, please. Bye everybody. Have a good day.
Bye, sir.
Alright, cool. Bye-bye.
Yes, sir.
Alright, bye.
Data, sir.
Alright, bye Ashton. Cool. I'm gonna end now.